Okay, so we have some data here, and we have basically this was a drugs effect study. So we've got 10, 20 people who go out clubbing or to a nightclub on the town. And on the night of they go before they go out, 10 were given the drug ecstasy and 10 were given alcohol. And then basically for each of these people, they were measured on this called a depression inventory. So they were measured on the Beck depression inventory um, basically at two stages, directly after they've been out the night before and also 4 to 5 days later. So there's basically kind of almost four sets of measurements here. So let's just have a look. We have our alcohol group. So we have the alcohol group. And then we have the ecstasy. And they were tested the day after, which would be Sunday. And they were also tested Wednesday. So there were basically 10 people, doing alcohol. So we had 10 pieces of data, 10 pieces of data, 10 pieces of data, and another 10 pieces. What happened there? Sorry. Another 10 pieces of data. Okay, so let me get a different kind of color pen here. Let's do the Galaxy pen. Now we're going to have a test for the difference between alcohol and ecstasy. These are two different groups of people. So we're going to test on Sunday the difference between, oh, I like this pen, Sunday alcohol and ecstasy. Now this would be a Wilcoxon rank sum test. And then the same again on Wednesday. We have another Wilcoxon rank sum test. Let's do the red. Now for alcohol, we want to test the before and after. It's not really before and after, but a little bit after and a lot after. So we're going to test the difference in alcohol with Sunday and Wednesday. So, maybe somebody who drank alcohol was okay the day after, but got depressed by Wednesday. Similar test with the ecstasy. And each of these is a Wilcoxon signed rank. Okay, so let's have a look at the data, which I've got in SPSS. It's the two sample drugs. It's in Canvas. So again, you can see we've got each of the drugs, and the drug is actually coded. We have ecstasy as 1 and alcohol as 2. And then we have the Beck depression inventory recorded on Sunday and recorded on Wednesday. So to start off with, we're going to do some exploratory data analysis. So what we're going to do is we're going to do analyze, and we're going to do descriptive statistics, explore, and what we're going to do is our dependent list is going to be the 2 Beck depression, and we're going to factor, so we're going to separate it out by the type of drugs. And we're just going to have the standard statistics, but we do want the normality plot. We don't want the stem and leaf. We're going to have the histogram. We want the normality plot with test, and we want an untransformed kind of Levene's test. Give it a second. Here we go. Okay, so we have the test of normality, And we can see this is a small sample, and the ecstasy value on the Sunday and the alcohol value on the Wednesday are not normal, which indicates small sample, not normal. We by Kolmogorov-Smirnov and also by Shapiro and Wilk. Both have very low p-values. So it indicates we don't have a great deal of normality. Okay, so here we have homogeneity of variances. The book that we use actually doesn't need this assumption. We just have the sample of differences is randomly selected from the population of differences. And we have this, underlying continuous probability distribution, even if our rankings are actually ordinal. But kind of as I mentioned, if we want to treat these tests as differences between medians, then we actually do need to have similar distributions. And the homogeneity of variances is one way of testing it. So we can say we're not normal and we have relatively homogeneous variances. As we're not normal and we have a small sample size, we need to use a non-parametric test. Okay, so let's just do, firstly, let's just kind of look where we are. Let's do the Wilcoxon rank sum tests. So we're testing between alcohol and ecstasy for Sunday, and we're testing between alcohol and ecstasy for Wednesday. So let's just go and do these tests. So we're going to analyze, and we're going to be non-parametric tests, which are down here. And we're going to be doing independent samples. And let's just go to fields. And it's got a bit of intelligence. So it's got the Beck depression inventory, Sunday, Beck depression inventory, Wednesday. And we're grouping by type of drug. And let's just see if it's picked the right test. We're not going to automatically choose the test. We're going to customize. Now, notice we said Mann-Whitney. As I said, the Mann-Whitney and the Wilcoxon rank sum test are the same test. And I've never, ever run a Moses extreme reaction test in my life. So there's a lot of weird and interesting tests on this tab. Okay, so we actually have two sets of kind of output here. We have the output for the Wednesday and the output for the Sunday and then the output for the following Wednesday. Notice the most important thing is we have a p-value. So we're going to reject the null hypothesis of being distributions having the same locations if your p is less than a certain alpha. So for Sunday, we have a large, say we're selecting alpha equals 0.05, we have a p-value of 0.28. So we would reject the null hypothesis that there's a difference in location of distributions. However, on Wednesday, the p-value is less than 0.001, which is lower than our kind of lowest standard alpha. So there is a difference, between the location of the different distributions. One distribution is either shifted to the left or the right of the other one. So beyond the p-value, what can we see? Well, this is the Sunday, and you can see we actually have frequency charts for the different scores. So we can actually see here that they're pretty, this is kind of like the population pyramid that you did, in week 2 of the class. You can see that ecstasy and alcohol, there's the mean rank for ecstasy is a little bit higher than the mean rank for alcohol, but there isn't a huge amount of difference. But if we go to the Wednesday, by Wednesday, the people who have taken ecstasy kind of have this delayed depression. So the depression is much higher for people with ecstasy than for alcohol. So we'd look at the p-value and then we would actually make some interpretation. Again, because we're using the we have the Wilcoxon statistic, but I don't want you to kind of start looking for critical regions. It's all going to be on the p-value. Now, notice we actually, in the more detailed version, remember the p-value at the top was 0.28. We actually have two p-values. We have 0.28 and 0.269. The 0.28 is for the actual Wilcoxon rank sum test. The 0.269 is we assume we do we kind of assume a pseudo-normal distribution, and we do a normal distribution version of this. And we actually have a z-score. So it actually kind of calculates from the test what a z-score would be if we were doing a z-test. So here you can see the z-score is minus 1.105. So the magnitude is pretty low. And this is where we're getting the 0.269. I don't want to double click, 0.269 p-value. But here you can see minus 3.484. So obviously, this is outside the range of any critical kind of rejection region for a z-test. And again, you can see the asymptotic sig is less than 0.001. Just one more thing, I have a slide. We can actually, again, we've got this z-score, and as we have this kind of z-score, we can actually do an effect size, because the relationship between an effect size and the z-score is generally, the magnitude of root n. So we could actually, again, do this kind of almost, it's not particularly rigorous, but this kind of estimate of an effect size. We just take our z-score and divide by root n. In this case, we have a total of 20 users for the Wilcoxon rank sum test. So we have like the z-score for Sunday, which is going to be relatively low. So the effect size, which is kind of the equivalent of the one sample Cohen's for Sunday, is minus 0.25, which is quite small. If you can recall, for the kind of the Cohen's d, which is pretty much the equivalent of 0.2 is small, 0.5 is medium, 0.8 is large, and then the Wednesdays, obviously there's a much stronger effect, and we get an effect size of negative, effect size of 0.78, so almost kind of a large effect size. Okay, so going back, we've done our two, ecstasy alcohol tests, one for Sunday and one for Wednesday. Now we're going to test the difference between Sunday and Wednesday for ecstasy and the difference between Sunday and Wednesday for alcohol with the two Wilcoxon signed rank tests. So this was actually a little bit more difficult, because if we want to kind of split and to get two different tests, we go to data, split file, and what we want to do is we want to put organize output by drug groups, and this is on the type of drug. So this is just saying, when we do a comparison of Wednesday to Sunday, Sunday to Wednesday, if we didn't do this, we would just get one Wilcoxon signed rank test for all 20 observations, Wednesday versus Sunday versus Wednesday. Okay, and now we've split, we can go back to non-parametric. So analyze, non-parametric test. And again, this is just the SPSS terminology for like, the paired test. So we're going to do related samples test. And again, we're going to go to the fields. And this is pretty much, we don't have to kind of change anything on the fields, because we've got the fields, the type of drug, we've got the test fields, Sunday and Wednesday, and the settings. We're just going to customize the test, and we're going to do a Wilcoxon matched pair signed rank test. And again, a few of these I've never run a Kendall's coefficient of concordance, and I certainly never run a Cochrane's Q test. Okay, so let's run these and get the output. So the median, here we have the first have the test for ecstasy between Sunday and Wednesday, and we have some significance here. We reject if we were less, reject less than alpha if we were using alpha equals 0.05, but not equals 0.01. So we have marginal significance. And what we do here is we can see that we have also the z statistic. So we have 2.5. That's like our Sido z statistic in the detailed section. We have, again, our 0.012. And then we actually have the positive differences and negative differences. So all of these 10 actually got more depressed by the Wednesday than they were kind of on the Sunday. So here we are, Wednesday minus Sunday. So let's now go to the alcohol. And this is, it's marginally significant, but it's a a little bit less significant. So we have a significance of 0.047. So we just about failed to reject if alcohol equals 0.05. And again, we can see with our kind of Sido Z test, we have a Z of minus 1.99. So we'd actually just about rejecting the equivalent Z test. And an asymptotic significance, the significance of the Z test is almost, it was exactly the same as our significance. And here you can see that we actually have, Wednesday minus Sunday, we actually are less depressed on Wednesday. We're kind of more, I guess we're more depressed on the Sunday because we have a bit of a hangover, and by Wednesday everything's cleared and we're happy again. But it's not quite as strong because we just have one we have one kind of outlier with a very large difference here. Okay, so let's just kind of go. And again, we can actually calculate effect sizes. Note that there's an error. This was from the book. I need to kind of paint in a dot there. But we can see that for the ecstasy effect size, the Z value of minus 2.53 divided by the square root of 20 is minus 0.57. And the alcohol, we have minus 1.99. And again, divide by the square root of 20 is minus 0.44. And I guess this is like, the paired test, I always tell you the number of observations is kind of the number of items. But here, I guess it's just a peculiarity that when SPSS is doing its kind of Sido Z statistic, it assumes that we have the 20 observations. So again, we can kind of calculate the effect size from the Z statistic. Okay, so that's it. And then we'll move on to next